Okay guys, in our last couple of videos we've looked at the advantages to having a trinomial of the form 1x squared plus bx plus c when the c value is actually equal to half of the middle term squared. The reason being because we could always, if it is half the middle term squared for our c value, factor this into this form where what we get in the middle here, or in our factored form, would just be half the middle square, or half the middle term. So the neat thing about this is, if it is in this form, then we can factor it into this, which would allow us to more easily solve equations using square roots. Now, in our first video, we looked at trinomials already being in a perfect square trinomial form. In this video, we're going to look at is trinomials that are not already in this form. And so just to kind of point this out to you, if I said number 24, let's go solve this by completing the square, I notice that it already has an a value of 1 out in front, that our b value here is 6, and half of 6. If I were to say b is 6, then I want to have a c value that is half of 6 squared, which is really 3 squared, which is 9. The problem here is that's not a 9. So here's what we're going to do. We are going to force it to become a 9 by taking what's already there and just moving it out of the way. So in terms of completing the square, what we mean by this is we're going to take something that's not already a perfect square thing. I'm going to move my 3 to the other side here, but we're going to add in a value for our c value here that would be desirable. And recall that what we want to be true about our c value is we want it to be half of the middle term squared. So because our middle term is 6, and half of 6 is 3, and 3 squared is 9, what we're going to do is we're going to add 9 to the left side here in place of the 3. And because I added it to the left, I also have to add it to the right. So now the fabulous thing here is this. You see how fast I just factored that? As a matter of fact, I know that it has to become one of these because I forced it into this pattern. I completed, the square. So now that we have a perfect square trinomial, the question is, well, what do I put inside of here? And remember that whatever goes in here is just half of your middle term. So half of our positive 6 to begin with would be a positive 3. That's just what I'm going to put right here. And on the right side, I get this negative 3 plus 9, which is a 6. So let's talk about this here. If I were to FOIL this x plus 3 back out, x plus 3 times x plus 3, I would certainly get x squared plus 6x plus 9. And so this term here is valid, this factored form. And also this factored form is nice because now I've got a perfect square of something. So now we could just take the square root of both sides. And what we end up with is just an x plus 3 on the left. And on the right, I don't know the square root of 6, but I certainly am responsible for still putting a plus or minus out in front. So now the only maneuver we have left to make is to actually subtract 3 from both sides here. And as per my recommendation, we should always put the plus or minus second here. I'm going to put a big fat box around this, and I'm going to say, hey, we get negative 3 plus 6 and negative 3 minus 6. Now, or negative 3 plus the square root of 6 and negative 3 minus the square root of 6. Sorry. Kind of preoccupied with getting my calculator open here. I had to shut it down. But what I want to do now is this. I actually want to go and I want to get a couple of decimals for these two values here. So the way this is going to work, so I'm just going to type in negative 3 plus the square root of 6. Enter. And I'm going to hit second enter, and I'm going to go back and I'm going to put in a minus instead of a plus. So what we get instead are these two decimals right here. So now what I'm also going to do is I'm actually going to go graph this original quadratic function here, which was just x squared plus 6x plus 3. And when I graph this, what I'm hoping to see is that these two decimals that I got for these two zeros actually exist on my graph. So it looks like to me that we get two negative zeros, or roots, or solutions. One is between 0 and negative 1. And the other one is, let's see here, negative 1, 2, 3, 4, 5, somewhere between negative 5 and negative 6. So if I quit out of my graph here, you can see that we got somewhere between negative 0 and negative 1. Sorry, 0 and negative 1, and between negative 5 and negative 6. And so these two solutions here really truly are the solutions of the function, or we could say the x-intercepts as well. So the neat thing about completing the square is that we can take something that's not a perfect square trinomial, just move the constant to the other side, and then make it become 1 by just adding half of the middle term squared to both sides, as long as our a value is 1. So to cap off the last two examples in this video here that I'm going to work through with you, I do want to point out the fact that I'm only using examples in this video where the a value is explicitly 1, and so it does follow this pattern right here. So for number 30 here, one thing I want you to notice is that this constant that would normally be on the left, it looks like it's already been booted to the right. So if this is the case, then let's go ahead and do this. We say, what would I really, really want to have in for my c value here that would cause this to be a perfect square trinomial? So recall that our c value here, we want it to be half of our middle term squared. So if our middle term has a value of 8, we're going to get 8 halves squared, which is really 4 squared, which comes out to be a 16. So I'm going to go ahead and add 16 to the left. What I do to the left, I have to add to the right. But my favorite thing about this is, without even thinking about it, I know that this has to be a square of a binomial now, and that half of our middle term is what I'm going to put right here. On the right side, it seems that we end up with a negative 4 this time. So with something like this, hey, we've already got something factored here as a perfect square. Let's just take the square root of both sides now to solve this. And so what I'm showing here is that we get an example where we don't get real number results. As a matter of fact, we get plus or minus I root 4, which I know the square root of 4, okay, is 2. So we get plus or minus 2 times I. And the last thing we're going to do here is we're going to subtract 4 over to the right side. So we get negative 4 plus or minus 2 times I. Now I'm going to put a box around this, and we're going to write that we have imaginary solutions. Oh, my handwriting is just so bad on this thing. Sorry, guys. Imaginary solutions. But what I also want to do is I actually want to set this back equal to 0 again, and I just want to go to show everybody here on our calculator that if we were to actually go graph this, that this is a situation where we would certainly never hit the x-axis because we didn't get real number solutions. And so if we were to graph x squared plus 8x plus 20, then what we end up with is this parabola here that it has imaginary solutions because it never hits the x-axis, which the x-axis is the axis that contains all of our real number solutions. And so no problem that we got complex answers here. It's just, it means that we have a parabola that never hits the x-axis. Let's take a look at this last example. And the reason why I want to look at this last one with you is we're going to look at an example where maybe your middle term, it's an odd thing. So we're going to get some fraction action going on. So we're going to go ahead and add our constant to the other side. The idea is that we have something here that I really want to be a perfect square trinomial. It's just that I'm going to have to put in here the thing that I want in order for it to become one. So because our middle term here, our middle term is negative 5, we're going to say that the c value that I want really is half of my middle term squared. And so just like we did kind of in our last video here, we'll just treat this as a fraction. We'll square the top and the bottom. You'll notice that every time we square out this term, we always get a positive result. Positive 9, positive 16. This time we get a positive 25/4. And this is something that we need to make sure we add to both sides. So now with the left, you might be freaking out a little bit saying, I don't know how to factor this. But remember, when you factor a perfect square trinomial in this form, then what goes in here is always going to be half of your middle term. And so because half of my middle term here, or my middle term is negative 5, then half of that is just x minus 5 over 2. And we're going to write this as a perfect square. Now on the right side, it is important to me that if we can, we go ahead and find a common denominator. So this is not completing the square. This is just, you've paid attention before in your math classes, and you know how to find a common denominator. So because our common denominator would be 4, I'd say that I'd get 20 fourths plus 25 more fourths, which comes out to be really, truly 45 fourths. So let me scroll down here. We'll get ourselves a little bit more room. The left side that we've factored into a square of a binomial is x minus 5 halves, okay, squared. And on the right side, we had 45 fourths. So just as we would naturally do any other time, we'll go ahead and take the square root of both sides, meaning that we get left with just x minus 5 halves on the left side. And on the right side here, we're going to write down a property that I want everybody to be using. But it is this. If you take the square root of a over b, this is the same as the square root of a over the square root of b. Okay. Same thing, when we take the square root of a times b, we can always write this as the square root of a times the square root of b. It's kind of the same property, but with division. So what we're going to do is we're going to split up, okay, our radical to be over the top and the bottom here. And so a couple of things we need to talk about with this here. We do know the square root of 4. So I'll go ahead and I'm going to rewrite this up over here just because I need more room. But on the left side here, we'll just leave our 5 halves where it's at. We'll simplify the right side. I get plus or minus something over 2. And also with our square root of 45, this is something we should reduce. And so when I ask myself, well, what's a perfect square that goes into 45? Well, I recognize that 9 is a perfect square, and it goes into 45. So what this means is we can actually take the square root of 9 and write it out in front. So with what we've gotten, a lot of rewriting, we get plus or minus 3 root 5 over 2. And the last thing that we're responsible for doing here is just adding the 5 halves to both sides. And so remember that we put the plus or minus second. That means I'm going to write my 5 halves first, and I'm going to say 5 halves plus or minus 3 root 5 over 2. And last but not least, just because we have a common denominator between these two values here, this time I'm actually going to write just a 2 on underneath here. I'm going to write 5 plus or minus 3 root 5. This is all over 2 here. So unlike the last couple examples here, I'm not going to get decimals for these, but because I got real number solutions for this, 2 of them, 5 plus 3 square root of 5 over 2 and 5 minus 3 square root of 5 over 2, I know that if I were to graph this parabola, then it would have to hit my x-axis at 2 real values. So this is how we kind of use this completing the square to our advantage. You move the constant you don't want out of the way and put in the constant you do want, so that it does indeed factor down into a square of a binomial, which we could just use square roots to solve with. Cheers.